From projectile motion, and let's read the question first. Okay, so the question says that a ball of mass m is thrown with an initial velocity of v at an angle theta. Okay, with the at the highest point of its trajectory, the ratio of the kinetic energy to its initial kinetic energy is half. Okay, so it's a projectile motion question. Okay, that is given in the problem. So it's a projectile motion. It's a projectile motion. Okay, what is it based on? Kinetic energy is equal to half mv square. Okay, so kinetic energy initial is given by half mv square, where v has both the components. It is made up of vx plus vy, right? So it is thrown at some angle theta, which we have to find. Okay, so at the highest point of a projectile, if you see the highest point, at the highest point, you just have a Vx. So kinetic energy at highest point is equal to half mv, okay, half mvx square. This is the way you write the kinetic energy at the highest point. I will just reduce the size of this video. Okay, let's move on this. So it is given that kinetic energy at the highest point is equal to kinetic energy, which is initial. So half mv square cos square theta is equal to half mv square. Okay, so into half, because it is half of the initial velocity, right? So the v square goes, m goes, half goes, so cos square theta is equal to half, right? At the highest point, you just have vx is equal to v cos theta. That is why we changed it. So cos theta is equal to 1 by root 2 and theta is equal to 45 degrees, right? So the answer is 45 degrees.